interruption again. Back to you, Dima.
Yeah. Sorry about that. Okay, so let me speed up the variant a little bit. Again, variant is like a JSON data type. You can think about it like JSON document, but it allows strongly typed values. So for example, in your array, you may have a string, you may have an integer, or you may have a timestamp. So in this sense, it's like very friendly for schema evolution use cases and also for processing and for storage. So basically, like all the representation is very compact. And just to spend like a few seconds, how it's actually implemented is basically a binary prefix for every data value. So essentially, you can encode an entire type system, and then it's like it's self-describing mechanism. Variant is cool. Our customers love it. If you are not using it, now it's part of Iceberg, and Snowflake was part of the specification group. So we were actively involved there. If you didn't try it yet, we strongly recommend you to give it a go. Now, let's talk about geospatial data types, and I would like to spend a little bit more time on geo. Maybe a little overview how geotypes came to Iceberg, and a little bit of history of how the specification evolved over time. And the initial discussions, they started about a year ago, so more than a year ago in May 24. And Snowflake extended the initial proposal, which was mostly focused on classical geometry data type, which is basically a planar representation, more like, GIS centric and standard type representation. Snowflake proposed another addition, a geography data type, which I will talk in a little bit more details in a few moments. And basically it took about a year to complete the specification. And then on 10th of February this year, the Iceberg and Parquet specifications were merged, and now we have geotypes in both Iceberg and Parquet. A bit of overview statistics about both of these PRs. So you have almost exactly the same set of collaborators. You have about, 200 comments in the discussion for Iceberg, and equivalent mirror version of Parquet discussion took a little longer. And for me personally, it was an interesting experience because it was a different set of people with different backgrounds. So you have people with PhD and geographical systems, and you have people with computer science and database engineering background, and you have to find some common ground and agree on a set of standards and how everything comes together. Thankfully, both of the types, they converged. Basically, what you see in Parquet is almost exactly the same implementation that you see in Iceberg. And we have two data types as part of Iceberg specification. We have geometry, which is parameterized by SRID, which is basically a spatial reference identifier. It's basically a coordinate system. And there are several thousands of those, but this is more like classical GIS approach of representing data on a flat plane. So it's a planar data type. And all the mathematics, it's in Cartesian coordinates. And we have another data type, which is geography, which is basically based on an assumption that Earth is represented by a perfect sphere. And there is a blog post at the previous slide where Snowflake describes all of this in more details. Now, as for data, physical data encoding, the actual encoding is represented by WKB encoding, which is essentially a binary specification which encodes byte order and then type of the object, so it's point or line string or a polygon, and then a sequential run of actual coordinates, which are 64-bit double values. And as you can imagine from database perspective or from purely data processing perspective, this is maybe not the best representation, not the best encoding, because you would like to decompose these values and store, for example, like type of an object separately from coordinates. And then if you have some function where you would like to look at only X coordinate, you would basically have to go through all of this representation rows by row. And you would not be able to, use some specialized version where, for example, you look at only X coordinates and then scan only X coordinates. However, in the discussion, basically, interoperability won this argument that WKB is essentially like a pretty much common standard across the industry. So anyone who's using Python or using Iceberg or using any other GIS tool can write this data and can read this data. And this argument basically, took and more arguments essentially in this discussion. Okay, and Iceberg stores essentially all the data by storing data and, more importantly, metadata. And metadata essentially describes what's inside of your Iceberg tables and what's inside of your partitions. In case of a simple integer column, so for example, if you have a column with int values, Iceberg stores lower bound and upper bound, which would be like minimum and maximum values in this file. And it's a bit more complicated, not so much, but a bit more complicated in case of geo, because you need to store X min and X max values and the Y coordinate and then Z coordinate. And essentially, Iceberg encodes this as a concatenation of 64-bit doubles. But why do we need to store metadata? And I think this is pretty much obvious in case of geo as well as for other data types. When the data is written in different data files and data partitions, we encode bounding box, which fully describes all the objects represented in this partition. So for example, if for partition 1, we are asking some spatial query, does it overlap with, let's say, city of New York? For example, for partition 1, it's really obvious that we don't even have to open this file because there would be no overlap. And we can do this on metadata level. So we can skip processing the partition entirely without even touching it. And it makes a huge difference for all kind of workloads, geospatial workloads included. There is one very important difference and change for geography data type. What I would like to describe here is that for geography, bounding box information need to account for spherical edges. And an example that I choose is this line connecting Berlin and San Francisco. So imagine you would like to draw a straight line connecting Berlin and San Francisco, and I was using, in this case, a Google Maps distance tool. And on the right side, you can see it looks almost like a straight line. Okay, I drew it manually. Maybe it looks like I had a beer before I've done it. But other than this, it looks like, the minimum distance connecting 2 points. But on the right side, you see another line. And the difference is that the line on the right side is geodesic. So it's basically a line connecting 2 points on a sphere. And it may seem counterintuitive, but the distance on the right side of the spherical distance is actually smaller compared to the straight line distance. Although in this projection, because Google Maps uses Mercator projection, it seems like, the line on the left-hand side is smaller. And the reason is that if you fly from Berlin to San Francisco on this direct flight, which does not exist in real life, unfortunately, if you rotate look at the Earth and use some tool or maybe just a globe and try to convince you that this is indeed the shortest distance, so you may just take a thread and basically try to connect this 2 points. It does make sense from the spherical perspective. But why does this matter for Iceberg and why does this matter for metadata? And the reason is that basically if you take these two types and you would like to ask some very simple spatial query, for example, for a geometric object, what is the maximum Y coordinate of this line connecting two cities in the planar projection. And you will see that it's basically its numerical value. It's 5251, which is the latitude of Berlin. And it does make sense. Okay, you have a line connecting two objects, you have some maximum value. However, if you have the same object, the line connecting two objects, and then you ask for a spherical base type, you will see that the maximum coordinate is actually much higher. So it crosses Greenland somewhere here. And you may just store 2 points, but you will get, this some other coordinate there. And this might be a problem actually, because if you would like to compare and ask some query, your database engine ask some query, okay, how about this point in Canada? Is it covered by this polygon or it's not covered? And basically, spherical model will give you a different answer compared to planar model. And it's very important that if you are doing some pruning and you are doing some statistics based on aggregated values for files, you need to take this into account. So you cannot really prune out everything, because this point might still lie within the polygon. So the correct bounding box should be actually this case. So if you are using Iceberg geography data type, make sure that your query engine handles this correctly, or just use Snowflake. So Snowflake already supports geography and geometry data types since a very long time. And we have about 95 functions and 59 functions for geometry. And they are fully developed and basically cover a wide variety of use cases. Now, with the introduction of Iceberg geotypes, Snowflake treats Iceberg essentially as a first-class citizen. And basically everything that works for native tables at Snowflake would work for Iceberg tables. And this applies not only to functionality for functions, but also from the performance perspective. So we pay special care to Iceberg tables, and you may expect the same performance from Iceberg tables as from Snowflake tables. Now, some areas of improvement and something that I see coming in the following iterations of Iceberg specification. So one of them is additional support for spatial transform functions, which were part of the initial discussion, but there was not enough time to squeeze them in. And this would probably be included in the following specification. Then you may be able to use more complicated partitioning functions when you are running geoqueries. So for example, if you would like to use some space filling curves and then use this as a partition transform function in Iceberg. And I mentioned WKB, and there's another interesting open source project called GeoArrow, which is much better designed for data processing use cases. There was some discussion of including this as an alternative option to WKB, so I think this is quite interesting and we should pay attention to this. And for geography type, I think there might be some iterations where we may improve how pruning is working and how metadata is working to extend them from min-max representation that we just discussed to something that is better suited for spherical representation. And with this, I would like to mention that Iceberg Geo is fully developed and built in Berlin. This is the team and people who are making it happen. And with this, I want to thank everyone. Any questions?
Thanks for the talk. Who outside of Snowflake is working on Iceberg Geo? What companies, what contributors, who do you usually work with?
You mean from specification perspective? Yeah, so implementation is, I'm not sure. I know about some companies in this spec. Tabular was involved, and then Tabular was acquired by Databricks. Databricks folks were involved. There is a startup based in Seattle called Whereabouts, and they were one of the main kind of contributors to the spec. I think these are the key contributors. Maybe some other companies were involved, but.
Here, use the box. Yeah.
Which box?
Nice. Yes, thank you for your speech. I have a question. You notice this bounding box, which specify like min-max coordinates. Does this mean that Parquet file is also partitioned by this bounding box?
Parquet file is basically a file, and the Parquet file consists of smaller units inside of it. So it's also broken down into so-called row groups, which are like bigger aggregations, and each row group contains of pages. So Parquet file also included this min-max extension for geo, but only on the row group level. And Iceberg defines them only on a file level. So basically, from Iceberg perspective, you may skip some partitions for files, but inside of Parquet file, you may also write this metadata on a row group level. So if you would like to do finer grained skipping of some units of work, you may do it on a row group level within the Parquet file. But it's up to engine. I think row group is not mandatory statistics, so some engines may not write it. And then you may only skip row groups if the engine actually written them.
Okay, thank you. And I have one more question. I would imagine that geospatial data is might be used like in real time and heavy use in real time. Can you give some estimation how fast is read-write with this geospatial data? Thank you.
It's a very good question. I think it's also a bit loaded question because it depends on what configuration and what kind of workload. I would not be able to give you some specific number. If you would like to get some better idea, find me after the talk. We can talk about this.
Okay, thank you very much.
Sure.
Thank you.